All right, this is the setup here for letters H through L on Worksheet 3 in Worksheet 1 on Chapter 3. So what we have here is this is a parabolic motion. So when the ball flies freely through the air, it first does a parabola through the air, and then it falls an extra distance because of the height of the cannon. Now, I've over-exaggerated this drawing. This drawing is not made to scale here, so this would be a lot smaller because the cannon's not that big. Anyway, so for part H, it says calculate the initial horizontal velocity. Now, these are all the givens that we have here. A couple things. When one of the silent givens that we have, when a ball flies freely without any friction, the horizontal acceleration is equal to 0 because there's nothing to slow it down, and the vertical acceleration is equal to gravity. Also, a couple things we know is that the vertical velocity at the top here, this chart that we're doing here is actually for Chapter 2A, the first half of the parabola. Now, these two variables are the most important because they don't change. VI and A don't change regardless of whatever question you're looking at. So they're the most important. Everything else under here can change depending on the question or the circumstances. But we do know that the vertical velocity at the top, VFY at the top, is equal to 0. So from a vertical point of view, this ball just gets thrown up. At the top, it's equal to 0. Now, the net column for parabolic motion is not that helpful, except for maybe at any given instance or at any given instant. And it's very helpful for the first part where you're given an angle, the initial velocity of 44.7. Now, I got this speed, this resultant speed, when it leaves the cannon is 44.7 at an angle of 30 degrees. Now, how do I know that? That was the final velocity at the end of Chapter 1. So now it's the initial velocity of Chapter 2. So the first question, so you can pause it here and get your drawing down. All right. Now, the first question is part H. It says figure out the horizontal velocity, the initial horizontal velocity here, and then you have to figure out for part I the initial vertical velocity. So we can do this all in one setting, or one sitting, I should say. H is VIX. Now, I don't have enough information in the column to solve this algebraically, but I can use trigonometry to go this way across the row. So that's what we'll use. So whenever you're setting up a trig problem, you should draw a triangle. This is 44.7. That's the horizontal speed, the initial horizontal speed, and this is the initial vertical speed. And the angle here hasn't changed. It still gets launched out into the air at 30 degrees. So I'm going to solve for this one using the equation from the reference table. You can use K. I will use AX equals RA times cosine theta. Now, AX is what we're solving for. That's VIX, the same thing that A just stands for any vector. In this case, we're dealing with VIX. So we're solving for AX equals 44.7 meters per second. That's the resultant, or the net. Multiply that by cosine 30 degrees. You get an answer of 44.7 multiplied by cosine 30. It gives an answer of 38.7 meters per second. So now we have step 5. VIX is equal to 38.7 meters per second. Now, for part I, now we're solving for VIY. Now that we know that this leg of the right triangle is 38.7, we can use Pythagorean theorem to solve for it. So step 2 is the same. Step 3, now you can use SO if you want, or even TOA, but I'm just going to use the easiest equation, a squared plus b squared equals c squared. We'll just say that the side that we're solving for is A. Doesn't make a difference, it's either A or B. So we'll call that a squared plus 38.7 meters per second squared equals 44.7 squared, that's meters per second. So we solve for this. We're doing 44.7 squared, subtract 38.7 squared, and then we get 500, but now we got to get the square root of that. And we get an answer of 22.4 meters per second. So that gives us VIY, or side A, is 22.4 meters per second. We can put this back into our original chart. This is 38.7. This is 22.4 meters per second.